Okay, so today we're going to start with chapter 2 and also chapter 3. Actually, chapter 2 is a very short chapter. It's basically just like the general idea about what regression analysis is. So to provide an overall view of what it is and also the things that you need to do, all the steps for regression analysis. And then in chapter 3, actually, we start with the actual details about regression analysis. Okay, so the plan is for today to finish chapter 2, and then we'll start with chapter 3. Okay, so first, kind of like a general definition of regression analysis. And basically, when we think about regression analysis, so this is a statistical method concerned with relating what's called a dependent variable. Sometimes it's called an outcome variable, a response variable, to a set of independent variables. So what we have, again, is a response variable. Sometimes we call it dependent variable, or sometimes, some literature they call it like an outcome variable, and usually we denote this variable by y, okay, to a set of independent variables. And I'm going to denote it by x1, x2, up to xk. And again, these are called independent variables, or sometimes they are called predictors or explanatory variables. Predictors, independent variables, or sometimes they are called explanatory variables. Okay, so for this class, and usually I guess following more or less the terminology that we use in economics, I would tend to call it dependent variable or outcome variable, and the independent variables I would call them usually explanatory variables. Okay, so that's kind of bad. The other terminology is also valid. Okay, and this is kind of like the general form of the model. So we have the outcome or the response or the dependent variable. Okay, so here what we're saying is that the values that you observe for this outcome, okay, are given by values for the average value of that variable so sometimes that's also called the systematic component. And also the second component, which is the error term, or sometimes, of course, we can say that's the non-systematic component. Non-systematic component. Okay, so another way. Okay, so let's see. Another way to think about it is that you usually observe a value for y. So here what we're saying is that the value that you observe for y, has two components. One that is what's called a systematic component. So that's the component that we can model. Okay, and then we have this other component that is kind of like very random things that we cannot model. Okay, now. Now, even though every time that that we write a regression equation, we include these two components, but actually the main focus of the analysis are what we have here in this systematic component. Okay, that's kind of what we mainly focus. Yes, you see, when we do regression analysis, we take into account the error. Of course, that's something that we cannot really model. So what we're actually modeling, and the focus is most of the analysis, is this systematic component. And then, this systematic component is related to the average value of y. Okay, and I'll go back to that because that's very important. Now, so remember, by the definition, we were saying that And regression analysis, what we're trying to do is we're trying to relate, okay, the values of independent variables or explanatory variables to the output. And the way that we do it is through that systematic component. Okay, so you see the systematic component, so what we're going to be doing in regression analysis is to make this systematic component a function of our explanatory variables. So I'm going to give you some examples for that systematic component. And also remember, I mean, previously we had talked about this is the expected value of y is nothing but the mean value of y. So another way to think about it is that what we're going to be doing is we're going to be modeling the average value of y as a function of the explanatory variable. So specific examples, then this is the first model that we're going to be talking about in chapter 3. So you see this is the simple linear regression model, where what we're doing is we're saying that the average value of y is only affected by one explanatory variable. And this is the simple linear regression model. Simple linear regression model. Now, we also have what's called the multiple linear regression model, where we have, more than one explanatory variable affecting the average value of y. Okay, so this is the multiple linear regression model. Okay, and once again here, what I want you to remember here is that the systematic component corresponds to a model for the average value of y. Okay, so the systematic component corresponds to the average value of y. Let's say to a model for the average value of y. So another way, and I guess I have never talked about this before, but another way to define regression analysis, basically using regression analysis, what at the end we end up doing is relating some explanatory variables to the average value of y. Okay? Again, so have that in mind. And I'll go back to this concept. Regression analysis, basically what we're doing is we're relating some explanatory variables to the average value of y. At the end, that's what we're able to learn. Because again, we did have this random error that is part of the model, but it's random. Okay? So the focus of this model is in this systematic component. Okay. So that's kind of like a general idea of what do we do in regression analysis. So, and I usually, so I guess I have updated this thing. So usually, when we're doing regression modeling, one way to think about all the process to do regression modeling is a process that involves basically 5 steps. The first one, you always need to have in mind what's going to be the form for this average value of y. Okay, you cannot start from scratch. You need to have an idea of what was going to be the model for the average value of y. So what's going to be the relationship between x and the average value of y? So, different ways. So if you think about it in the context of a simple model, you might think that that relationship is expressed by a line, like an upward sloping line. Or you might think that the relationship between x and the average value of y is given by some parabola. or that the relationship between x and the average value of y, is given by some, type of curve that asymptotically and it's going to touch certain numbers. Okay, the main point here is that when you are doing regression analysis, you need to have in mind what's going to be the relationship between x and y. So for example, in the context of economics, the typical example is the context of demand analysis, when we know that as prices increase, the quantity demanded of a good is going to go down, which is basically to correspond to this third graph. So you see, even before you run the regression, you need to have an idea that the relationship between x and the average quantity demanded is going to be one where you have this kind of downward slope type of curvature. Okay, that's kind of going to guide everything that you do in regression analysis. So once you do that, the second step is going to go and collect some data. Of course, with data, in some cases you will collect what's called primary data. So it's when you collect yourself, you go conduct a survey. You collect it. Or it can be, so the other type of data is what's called secondary data, which is data that has been already collected, but you can use it for your analysis. And a lot of statistical agencies already collect data. Again, so that is if it's already collected. Okay, so that's usually the second step. And once you have data, you can use the data to estimate the unknown parameters. Okay, so remember, usually we start with an idea of what is our model. And again, I'm going to use this simple linear regression model. You see, we start with the idea that that's our model. Sometimes we call this model what's called the population model. And of course, we don't know the beta naught and the beta 1. Okay, so you see, these are the coefficients of our model. So what we're going to be doing is we're going to be collecting this data to try to estimate these coefficients. So that's what we do there. And then we end up with what is called our estimated model. So this is for the sample regression model. So note here that, I have used these hats, and I had mentioned before, I think in the previous class, sometimes to differentiate between the values in the population and the values in the sample, we use these hats. Okay, so this is the model that we think exists in the population. This is what we want to know, but this is what we're going to be able to learn using our sample value. Okay? So again, I guess I had mentioned before, values with hats means estimated sample values. So they mean estimated sample values. Okay, so everybody's kind of following. So remember, if you're going to do regression analysis, you need to have an idea of what's going to be the relationship that you're trying to estimate. You can think of that as the population model. So once you have that idea, you go and collect some data. Then you use that data to estimate the unknown parameters, okay, using regression estimation procedures. That's what we're going to be learning in this class. Okay, there are methods and formulas that are used to estimate these coefficients. So, once you have estimated the model, you can check if the model is useful or not. And here, there are going to be a lot of different ways in which you can do it. I know that even if you took a basic stats class, you heard about the R-square, which is kind of like a measure of how good the model is. But there are also some formal tests. And these include, for example, a test that's called F-test and another test that's called T-test. So, those tests can be used to check if the model is useful or not. And once you have a model that you think that it's useful, you are going to use it for whatever purposes you wanted to use the model for. For example, in some cases, especially in the context of business, you might want it to predict what's going to be the Y in the future. So predict Y for the future. Yeah. So, if, for example, sales. Yeah. So, as a matter of fact, actually this morning, I was hearing NPR. And they were talking Amazon. So you see that Amazon, the way they do, the companies that selling Amazon and Amazon themselves, the way they do is they forecast the demand of certain products, like in certain areas. So for example, like before classes began, they forecast that the amounts of textbooks for first grade kids that follow the Texas standard are going to be, 300,000 textbooks for first grade. And probably, that's what they're going to send to the, they have the big warehouse in San Antonio. San Antonio? Yeah, I think. I've seen one in San Antonio. And I don't know if that's what they use as the warehouse to distribute the books. So you see, they use a model, a forecasting model, to try to predict what's going to be the actual demand. And the big problem that they were saying, sometimes in some cases, the predictions are going to fail. So the question is, what is that they're going to do with all those books that were not sold? So they were talking about, sometimes they just throw them away. So this morning they were talking about Amazon partnering with some company who is giving away goods and books, etc. So instead of throwing them away, because it's expensive to have them in the warehouse, they take space for some other things that might be, they need that space to buy, toys, like for Christmas, instead of having those books piled up there. So, so you see how important is the forecast. The point there is, you can use a regression model, and I'm not sure what type of models they're using. Very likely to be models very similar to regression models, probably more complicated ones, but you see that's an example where your model is used for prediction. Okay? And, of course, the better the prediction is, the less waste that you're going to have at the end of the season, or whatever type of shopping season. Okay? So, that's more or less an idea, the big picture. Now, for purposes of our class, we're going to be using a lot of different examples. And, for most purposes, we're going to be assuming that we already know 1 and 2. That's not really part of the class. If you are an expert in nutrition, you know more or less, So the relationship that you are hypothesizing, it comes from your knowledge. Okay? Or, you're an animal scientist, and you are interested in, daily weight gain. Yeah, exactly. So, the weight gain, and you have a certain mineral or whatever. You assume that you give it this additional mineral, the gain, the gains in weight are going to be higher or whatever, okay, or lower. If it's something that it's bad. So that's what you know. So we're going to be assuming that you already know that. Regarding data collection, again, for our purposes, we're going to assume that we already have the data. And, we're going to be using a lot of data sets ready available for our purposes. So we're going to be focusing in this class in steps, 3, 4, and 5. Okay? That's basically what we do in this class. So, we will learn how is that we go about estimating these coefficients of the model. We will learn how to go about, checking the usefulness of the model, and then, how to use this model for different purposes. So this whole class involves steps 3, 4, and 5. Mostly, once in a while, we'll see that some of the things that we do, of course, they have a relationship with 1 and 2. You might have an hypothesis, you run a test, and that might go against your hypothesis for whatever reason. So, we'll learn how you can go back and relate to these things. Or, some of the things that we need to do in step 3, 4, and 5 have implications regarding data collection. Okay? So, but, mostly, really the class is about steps 3, 4, and 5. Okay, so do you have a general idea of what you need to do when you're doing regression analysis? Which is basically the same thing that you need to do when you do any type of statistical analysis anyway. You always start with an hypothesis, think about it. You go and collect data, and then, using the formulas for the statistical test, you find evidence against or in favor of your hypothesis. And then, after you have done that, you can evaluate the validity of the test or not, and you use whatever result to make recommendations or policy recommendations for, if you are in the medical field, like Eduardo, to make recommendations to use or not certain medicines. So it's the same thing. Okay? So basically it's the same thing that we always do in statistics. Okay, so and that's basically the introduction to regression analysis.